Okay, welcome to our first lesson in the new unit on organization of data for analysis. This will be the unit that will take us into statistics. But before we can actually collect data, we actually have to determine how to collect that data and organize it so that we can do it. So there's a bunch of things that we're going to be able to do in this unit, but our conversation is going to center around the idea of variability, the idea of bias, and we're going to look at variability and a couple definitions of validity and reliability as well. And so here we're going to concentrate on variability in the conclusions and the different types of data that we can see, and that will help us to decide what the conclusions are. And so I'll also demonstrate some things in UG Cloud. So by the other end of the unit, you want to be able to design a survey for your culminating project. And so you want to understand the variability in the data and how that's affected by reliability and validity. We want to apply our knowledge. We're going to actually write a test in this unit and just draw conclusions from real world data and situations, apply principles of data collection, critique steps in the process of data collection. Throughout the unit, we're going to be talking about this idea of variability inherent in data. This is the idea of the extent to which different conclusions can be drawn, or data can just be different. So in collection of data, we can see how different two sets of data are collected. But then if we're just looking at conclusions, we can see if you're looking at the data versus I'm looking at it, or by the way it's presented, those conclusions could be different. And we really need valid and reliable data to control variability, control the extent to which things are different. So here are the definitions. Variability is the extent to which conclusions or data are different. Reliability is this idea of the law of large numbers, where results of a study should be able to be duplicated. More trials will produce more accurate data. Validity is the extent to which data represents opinion of the people being studied, or the results of the entire group from which you're sampling. And so it could be people, it could just be a bunch of things that you're actually looking at. So first learning target, we're looking at variability in analysis. So our first goal is to understand that people can draw different conclusions from the exact same data. And how is that possible? It's just the way it's represented. So you look at something like this here, reading this graph, you can say, wow, there's a lot more males than females at Eastern High School. But if you look closer, you don't really see that same thing. There's a kind of a neat link here that you can click on in the lesson notes on 5 ways to lie with charts. And I'll give you examples. Healthcare data. So we want to look at something in Google Spreadsheet, but we also want to look at it in Fathom. And so we're just looking at healthcare data, life expectancy in healthcare. And so we've got this spreadsheet in Google Docs, and it looks like this. And so I actually want to show you how to just make the graph in Google Docs. If we highlight, I find that students have trouble highlighting just because with the spreadsheet we just got to make sure we click in the middle and slide over. I actually like holding down Shift and just using the arrow keys. So you can see my mouse isn't even moving, it's my arrow that's moving. What I can do is I can click Insert Chart, just like we've done before. We're going to go to a scatter plot, and so we see something like this. When we insert it, this is the data we actually get, and so we've got the spending on the x-axis. How does spending affect your life expectancy? We could also look at this the other way around. How does life expectancy affect spending? And notice how it is pretty spread out. We've got a special point here, which unfortunately in Google Docs, it's really hard to see. We can change this graph to, let me just delete this graph for a second. We can highlight this and go to Insert Chart. and just use row 1 as headers, and we can go to a scatter plot that way. And when we insert it, at least it's a little bit better because like the points are spread out, but at least it gives us an idea of who's what. So the United States are here, but it's really not that good of a graph. We can go to edit the chart again. It just gives us the same screen. So there might be a way to make the bullets smaller, just so that you can see better. But certainly you can like mouse over and see more information right in the edit function. If you go to the customize and go to the axis and change it to the left vertical, we can actually set a minimum of the axis to 0. We saw that actually in the male-female graph, and you can actually what happens then is everything changes, and so I'm gonna change this graph back because it's really not that good without the titles. If you ever make a mistake, you just hit undo. As I said, the arrows are a little bit better to use. So if I highlight these points, we go to insert chart, and then we go to scatter plot again. What I can do is under customize, I can click the left vertical axis. This is this guy, and I can change it to a minimum of 0 instead of 74 or 70, and then I can look at my graph and see what it looks like. You can see, like, depending on what I really want to highlight, like I can say that, oh, see how much life expectancy, or sorry, your spending doesn't really impact your life expectancy. Spending changes a lot, but life expectancy is pretty much the same as we go. And now there's something else we can do in Google Docs. I just want to show you. We can actually pick a scatter plot with a line through it. Here's the trend. I know we could do it in Excel. Okay, let's not worry about that for now. I want to show you something else, like that a program that we're going to use is called Fathom, and it's really helpful. So if I just download the healthcare data in the UG Cloud web folder, and I open up this, and we actually had data all set up for us. And so what it shows up here is a table. The Fathom, there's all these little data sets, and they're called collections, and you can actually do stuff with those collections. And you can actually import a collection in. If you create a collection, you can actually copy and paste cases from Excel that you've highlighted, which is a really helpful thing to do. Or you can click on, and you can also click on the collection when it's in and bring in a table, just drag and drop. You have to be clicked on it to actually drag and drop. And then when you have the table in, we can actually pull in a graph, and it doesn't graph it right away because it doesn't know what you want to do. So we can see what impact does spending have on life expectancy. So same idea as in Google, and I can make it bigger. You've got this idea that is spread out, really, right? Like depending on your spending, you can say your life expectancy goes up. It also quite easily, if you right-click the white space, you can insert what we call a line of best fit, a least squares line. You can see as spending increases, your life expectancy goes up. And we'll talk about what these numbers down here mean in the stats unit. The problem with this conclusion is, like you can see how scattered these are. And so you could see, well, I mean, or not necessarily the problem with it, but you can make a conclusion that as spending goes up, life expectancy goes up, just by looking at this graph. I like Fathom because what you can do also is you can highlight one of these points and actually click on them, and it'll come up like that's Austria. It'll highlight Austria. It'll show you what Austria is. Also down here in the left corner, you can actually see what this guy is, United States, and it's got all the points there. You can click on United States, and you can see that United States comes up down here. You can click on some of the other outliers. You can click on this guy and find out that's Japan. So lower amount of spending, incredibly, it's got the highest life expectancy in Japan. It's a whole bunch of conclusions you can make from this graph. Now, if you right-click the graph and go to Inspect Graph, you can actually change the properties to have a, and if I'm going too fast, you can just rewind it or pause it or try this on your own. But you can right-click the graph and click Properties, Inspect Graph, and then just click the Properties tab. And you can change the Y upper and Y lower right there. You just got to find it. Y lower, you can change to 0. So the same idea, like we look at the graph and we can say, you know what, there's not really any impact on life expectancy with spending. Like, it's pretty flat. And indeed, like, this number here actually tells us the slope, but it does actually look pretty flat. But when the scale is so small, or the vertical axis changes, you can see it like a lot bigger spread. And depending on how you might want that, but depending on how you want to present the data, you can change the vertical axis to see it, as long as you don't lie and have the vertical axis not make sense. And so, which people do as well. They can come up with a different conclusion from the graph because their vertical axis doesn't make sense. Okay, so that you can play around. That vertical axis is a way to change the variability or change the conclusions in the data. It's a way that we can get variability in the conclusions. Okay. So you can look at page 200 for some other questions. The y-axis scale has a tremendous role in the conclusions that we can draw from the data. Second learning target we're going to talk about is types of data. So we've talked about numerical data as continuous or discrete. It takes any number, continuous or discrete. We've talked about that a lot in our last unit on the normal distribution. The second part we're going to concentrate in this unit is the categorical data. We're going to find that there is a type of categorical data that we can use numbers for, but we call it categorical. And it's what you would think it is the data that can be arranged into categories. Two types of categorical data, and the way we kind of remember what they are is the nominal order means nominal data is no order, and ordinal data is order. So nominal is groups or categories not ranked, so we can't say like one eye color is higher than another. And ordinal data is where groups or categories are ranked, so we can call them learning skills. Sorry, for example, is a provincial learning skills, needs improvement, satisfactory, good, excellent. We could change, notice how in ordinal data we could just change the numbers to, like the letters to 1, 2, 3, 4. And there is a ranking system here. So to know the difference, it does help to know something's ordinal because you might want to look at those numbers. So you might care how many people agree or strongly agree. Like those are categories, but they're ordinal categories. So I want to look at another file from Fathom that we can play with. So Youth Survey. So this is the Ontario Youth Survey, given out every year. The textbook talks a little bit more about it. And so if we look at the data collection, we bring in the table. And so again, we can actually see what types of data are nominal versus ordinal, depending on the graph, and I'll give you a better idea. So you can see, like, here's a question: I feel safe at school, and so something that's really important to schools to make sure that their students feel safe. We could just drag and drop that whole variable into the x-axis. This is a bit different graph than before. It's the bar graph. And so what we do, this is what we call ordinal data. And so what we care about is the order. And so if never comes, we care about never. That's probably like a 0. That's really bad. I rarely feel safe would be second. Some of the time I feel safe. Most of the time, all the time. Notice how really benefit to putting it in this order. And so with ordinal data, if you have ordinal data, you really want to put it in order so that you can see this kind of progression. We can also replace this ordinal data with numbers, and that's how we're going to do the survey and the culminating assignment. Just get people to rank from 0 to 10. Actually put numbers on it. So then we can do things like averages and standard deviations. Okay. Another graph we wanted to look at was the what are you going to do after high school? And so we look at this graph. We can make it big. Remember that it's only one variable, so we put it on x-axis, and the y-axis is the number of people that are in that category. I'm just going to put it down a little. Okay. And so this is another one I want to look at. And so the thing about this isn't ordinal. We can't just put these in an order. Like, you might think completing a university degree goes here, but somebody else might think that college is actually better. I know people that make more money with college diplomas than their university. But then, we don't even know what other is. So that could be the highest. I don't know. Why is I don't know any worse answer than university degree? I've seen a lot of people knowing that they're going to go to university but wasting the money. People that I don't know that are waiting it out, that's a different category. The point is, doesn't really matter what order we put these in. They're all unique answers. There's no order to these answers. And so that's really important when we understand nominal data. There's no order to the answers. Okay. So some practice questions, so you can read through these questions on 203. It's really important you go through these questions so that you understand the kind of questions that you're going to be asked, what you really need to understand, be able to articulate. You can also research online. It's really kind of fun to do this. Example of data that are accurate, but they misrepresent the information. I'll never forget this article in Sportsnet with Connor McDavid. 2 games into the season, his average goals per game, just a ridiculous number. And they're trying to compare it to his last few seasons and saying how he's better than ever. And the season was only 4 games in or something like that. And so it's really, and they've got this bar graph. The bar is gigantic versus the other ones, and I noticed that a lot. It's actually really interesting when you notice that kind of thing. Okay.